Hey everyone, and welcome back to K2N Academy. Today we're going to dive into a super exciting and important topic in the world of AI, that is prompt engineering. Now you might be thinking, what is the big deal about writing prompts? We've all been using ChatGPT for ages, right? Well, prompt engineering isn't exactly just typing questions and getting answers. Rather, it is a calculated method of crafting prompts in such a way that you get desirable results. In this video, we're going to break down on how you could craft prompts in such a way that you get accurate and reliable results from AI. Also, stick around to the end of this video as we're going to have an AWS AI ML class that you could attend for free. So with this, let's continue on with the video.
All right, so prompt engineering. Basically here, we'll be learning this prompt engineering in and out. In fact, I'm sure you might be wondering what's so difficult in that, or not what's so difficult, rather what's so much to discuss about that, right? Because prompt is something that we are always doing. We are already using ChatGPT and everything, right? In daily life. And yes, the Meta as well, it has put out certain certain UIs, we are able to use that. We are aware of the prompts, but believe me, it's much more, what I can say, it is much more technical than what we think. Okay, it has to be properly. Generally, what happens is, yes, we use the prompts and we get along, but how to refine those, how to make it more correct, how to make it more technically correct in order for it to understand, right? So today we'll see this in and out. Now, one perspective I'll just put in your mind right now, team, is think of your foundation model as that small kid, a very small kid who had just started to learn how to walk on its own. Now, it is your job to teach. Now, train would be not a good word from that kid point of view, but it is our job to teach that particular kid how to do all its day-to-day life activities and how to get it done. You have to make sure of that. Okay, so prompt engineering is exactly that. Here we'll be understanding how we can talk to our foundation model essentially and get the things done from it. Okay, in the best way possible, in a way that that kid could understand, in a way that that foundation model could understand, and even making sure that you're getting the task done, that too without making him or her cry. Okay, now our foundation model will not cry for sure, but might not give you the kind of response that you're looking for. So in that sense, it is important, team, that we have to understand how to talk basically with our foundation models. Okay, the very first thing that you have to understand, okay, like I was saying, was if you take this as your foundation model. Okay, now understand this very carefully. And you all know what is foundation model right now, right? I mean, nothing to discuss there, right? Foundation model. Now, in terms of this foundation model, we have seen that this foundation model will give us different kinds of features, right? Maybe you can see the content generation, maybe in the form of, let's say, your summarization, right? Or maybe, maybe in the form of, let us say, image generation, right? I'm just putting out a few of those. Or maybe in the form of what? We can have a chatbot kind of experience, right? So whatever you want to carry out through your foundation model, one thing is for sure that you'll have to provide it with some input, right? You see, input. Now, you see, what is this input? Basically, this input, whatever you are writing it down, right? What exactly you want to carry out? What is exactly that you're expecting it to give you? Okay, these instructions, we refer to them as prompts. Okay, so for example, if I just quickly give an idea about, if I just go back to our foundation model, right, that we have been using all along. So you see, this is my console, and let's just go for Bedrock. You know the process well. And here, let's just go for our playgrounds, and let's just go for, let us just say, chat playground. No, not chat. I'll just go for text playground. Okay. If I select any model for example, let's just go for, these are the models that we have. Okay, certain models we have already initialized. But timing, let's just select, I'll go for Amazon and select Titan G1 Express, or let's just go for light for that matter. Okay. Now, talking about it, let's just put a small prompt. Now, this is what I want to discuss. You see, you have selected a model right now. Last time we have done it, but we did not discuss it much. But we have selected a model, and in that model, you're writing the prompt here. And that's what makes it, or that's what kind of is considered as an input for your model. For example, let's just say I want to translate the following text from English to Spanish, for example. Okay, I don't know much of Spanish, but still that's why, in fact, I would rather do this. So the sentence is like, what is your name? Now, if anyone here knows Spanish, do let me know what's that, or how it's kind of put out. Okay, so I'm going to ask it, the model, and please do let me know if it is correct. Okay, if our model is answering it correct, because that's again a child that's a kid again that we are talking to. And whatever the information that it has, it will answer you with that. If it doesn't have it, it might give you wrong answers, right? So you have to make sure that it is in check. Okay. So now that you see with the huge information and everything, we are expecting it to be correct, but still just know that it is correct to the extent that it knows. Okay. So what is your name? This is the question that I have. And I just want to know how our model. So yes, I'm running it, and this is I'm not even so sure how to pronounce it correctly. I understand the notion of prompt is equal to input. Is the engineering part something we must implement to complement the foundation model, or is it just knowing how to form the input question? Exactly. So again, you see, the thing is like, as a part of generative AI, AWS, not AWS, rather, the vendors, they have created these foundation models. They have created it already. Okay, it is just a way we are trying to communicate with it. So prompt engineering is specifically talking about how the input should be designed. Okay. But yes, exactly. This is where we are going to discuss the various ways how the inputs can be formed. And as I've told you, it might seem that, okay, it's pretty obvious. What's so special in that? We'll see. We'll see why it is so important, why it is considered very important in the context of playing with the. Because you see, again and again, I'm telling you, the way you ask it is the kind of answer, or is the kind of output that you can expect. Okay. So let's just see how basically these prompts and everything that we've just now seen a small example team, but it is important to understand, okay, that the input matters a lot, because foundation model has all the information in the world. Okay, it has, to the extent that we have provided, of course, but still we have given it a huge amount of information. Now, how to extract that information, how to basically get the information of what you want, okay, and not getting any irrelevant information. That's where you'll see this prompt engineering, as we call it, it paves its way in. Okay, so in this prompt engineering, or this prompting with the various techniques, as we'll see, okay, we are going to focus on making sure that our prompts, whatever that we are putting out, we are optimizing. We are optimizing how we apply, how we develop, isn't it? How we make sure to have the appropriate quality associated. We want to make sure of that the prompt is of the quality that it will give you the required answers. As well, we're going to address the various shortcomings that a prompt could have. Right. And we are going to fix it in the context of talking to any foundation model for that sake. Okay. Now, as we've discussed, you see this foundation model. In fact, one of the diagram that we discussed earlier, even if you just go back a bit, you see this is the diagram that we are referring all along, this one, right? We have discussed a lot over here. Is that how the foundation models, they make use of the transformer in the backend, they make use of deep neural network, right? Underneath, I mean, you see foundation models, they're using this deep neural network to emulate or to rather mimic a human brain to give out or to carry out the task that you have given. Okay, and in order to do that, as I've discussed, we need to have, yes, it has been pre-trained, we know what to adapt to, but it's important now the final step under this, because everything is all set up. The only thing that we have to be careful with is the prompt. Right. Here, examples, these FMs, we have seen different examples as well, and we'll be exploring those as well. Now, one more thing, team. Now, this is a bit more technical. I'll not go too much into it, but I'll just give you an idea. Is basically when you talk about foundation models, no? If I just put it over here, because the way they are prepared, the way they are, in fact, designed, or the way they are configured, right? It matters a lot in the context of how you're going to talk to it, isn't it? Whereas if you talk about the traditional machine learning models, okay, there are something called to be, and this is something that we discussed, if you remember, a while back, was supervised. One of the sessions we had discussed it, or it can be semi-supervised, right? Or it could be unsupervised learning, right? I mean, this is the way, in these different ways, your traditional machine learning models are trained. Now, what is the basic difference? I'll just give you an idea. Is supervised is where your data contains not the raw data, but rather it is a labeled data. So that you see, your machine learning model could know exactly what it will know exactly what's inside that particular data, right? We just maximize this. Yeah. So with the labeling of data, for example, I have given you an example, if you remember in the last session as well, that when you're talking about such a supervised learning, okay, for example, let us say I've provided it with the image, okay, an image of a road, of a street, right? On the street, we have a car that's going on, that's kind of running through that road, or it's going through that road. So labeling that as a car, isn't it? It could be a label. For example, if you're talking about a car itself, okay, in that car, let us say you have labeled a windshield there, you have labeled a mirror there, you have labeled, for example, the bonnet there, right? The tires there. So supervised learning is all about providing this important information along with, so that your machine learning model does not have to scratch its head to understand that. So it's a more structured, more simpler way of training your model, but simpler from the context of the model, by the way, okay, not from our point of view, because as a user, you will have to spend a lot of time, a lot of energy, a lot of efforts on that. Okay, now talking about unsupervised or semi-supervised. Unsupervised is rather, you'll see that there is entirely raw data. In fact, if you remember, we had discussed that unlabeled data, right? Okay, unsupervised is basically around that, wherein your data is not labeled as such. Okay, wherein your machine learning model, you'll have to adapt, or you'll have to have some mechanism. Okay, now there are many methods and the way it has been done, but timing, just remember that it does have, you'll have to have some mechanism that machine learning model can itself understand the labels. Now, that's putting more efforts on machine learning model than on the human. So this is a trade-off you see between the supervised and unsupervised. And on the other hand, you see we have, and semi is again, as you can guess, it's more coming in the way, right? Just a second, yeah. So like I was saying, the one that's important to us is our Gen AI models, or the, not a Gen AIs, but rather I'll say the foundation models. Now, these are typically trained through what we call to be the self-supervised. self-supervised learning. Now, this is an entirely different and newer approach, by the way, team. Okay, wherein, in fact, let me just quickly take you there. In fact, there was a very nice document that I had seen. I'll just share you the link of that as well. I saw it on IBM, self-supervised learning. Now you can see, I think I had seen that already. So it's showing up there itself. Okay, so what is self-supervised? I mean, in a very nice few lines you can understand. Self-supervised learning is a machine learning technique that uses unsupervised learning for tasks that conventionally require supervised learning. Okay, so now this is important, rather than relying on the labeled data set for supervised signals, self-supervised models generate implicit labels from the unstructured data. Okay, again, you can see the use cases of it. We'll not go into too much of details of it. I'm just giving an idea of what that is. So, for example, if you just see a field like computer vision, where your vision should be as like a human vision. Okay, or NLPs, where in fact you're trying to understand, if you're trying to talk in a language that is more closer to us as humans. Okay, we require a large amount of label data to train our AI models. But the problem with the labeling, as I've told you earlier, team, as well, is that it requires time-consuming annotation. Okay, in fact, there's a concept, I don't know if they're mentioning a ground truth. Somewhere they might be mentioning that, I don't know. But somewhere it should be there. You can see here they have ground truth. In fact, this is a very common thing that we use in the SageMaker of AWS as well, while working with the traditional machine learning model. So that what I'll do is, for example, I'll provide the data to the users. Okay, in fact, this is very interesting. I don't want to divert with the discussion, but you'll see that there are literally people sitting at AWS and Amazon, or there are external vendors that you can kind of rent for this task, wherein you'll provide them the image and you are asking them to label it, to tell, okay, what is this, what is that, and what are the things that are present in the picture. Now, depending on that information, your machine learning model will say, okay, the humans are kind of identifying these things like this. Okay, let me just take it up and I'll just try it out on my own for the next tasks. Right. So it is like, again, for the same example, like I talked, right? A kid or a child who just saw his parents or her parents, how they are kind of carrying out this thing and that thing, and then just trying to do that on its own. Let's just have a small bird, in fact, isn't it? Just looking at the parents to see how they are flying and then be able to do it, right? So in the same way, you see machine learning models, they do as well, is when you provide them with the label data, then they will try to see how they can fetch their own data. In fact, this self-supervised learning, or rather we in fact have another name for it, which is reinforced learning. This is a very, very newer technique in the context of the older ones, which allows you basically, team, to learn on your own self. Okay, again, I'm refraining myself a lot from going in that direction, but just get an idea that machine itself is trying to learn the information. If it learns it, it will reward itself. If it doesn't, it will penalize itself. Very, very interesting. And it is newer in the context of learning. And you will see that in the very future, in the near future. In fact, it will take some time for sure, but in some time, you will see that machines won't require our information. That's true. Okay, they will learn themselves with these data. But as of now, okay, the future is far ahead. As of now, we have our foundation models. Yes, they are implying some sort of self-supervised learning, where they're learning on their own. They're trying to figure out the information. Okay, even though the information is not explicitly kind of given. Okay, and that's where these foundation models, they are becoming more and more powerful by learning themselves. Okay.
So there you have it. Prompt engineering is much more than just typing words into a model. It's actually a way where you could communicate with AI to get the most accurate and relevant responses. Now, when you master the skill, you can truly unlock the power of foundation models and get it to work for you in the ways that you could never have imagined. But why stop here? If you're ready to take your AI/ML skills to the next level, we have something really special for you, which is a free AWS AI/ML masterclass. So whether you're just starting out or you're looking to sharpen your skills, this class is packed with hands-on experience, real-world applications, and expert insights to guide you along the way. And you can register for this class by clicking on the link in the description below. Don't forget to like and subscribe for more AI related content. With this, I'll see you all in the next one.